In 2016, Josh Brown was killed when his car collided with a semi-truck. It was the first time an American has been killed in a self-driving car. The government report showed that the car had given several warnings prior to the crash, instructing the driver to take manual control. As companies are racing to get fully self-driving cars on the market, this tragedy brings to mind references to a future in which humans are vulnerable to machines. As of November 2017, 21 states have authorized self-driving cars.
I did not know that we had self-driving or semi-self-driving cars on the road today. And I guess that makes me feel a little nervous just because I didn't know the technology was there yet, and I only want to go in one if it's going to be 100% safe.
I think there's a potential for driving to be safer from self-driving cars, like in 150 years from now or something. But I think that that would be after a lot of trial and error and some deaths.
As states draft legislation, they will have to understand how these vehicles work to create divisions of liability. Fully autonomous vehicles derive precise environmental data by employing an array of sensors. This creates an understanding of the changing world around the car. Decision-making algorithms process this to steer, brake, and accelerate. These algorithms first create a world model using training data gathered from real drivers. This model is then tested against new data sets and evaluated against heuristics in order to refine the model. Of note is that no one explicitly defines this behavior. Though there are several classes of autonomous vehicles, we'll examine three which implement this technology to varying degrees. In the status quo of auto liability, drivers are liable when they are at fault and negligent in an accident. Driver liability cases are the most significant portion of personal torts in the United States. Auto manufacturers have largely been shielded from common tort claims and are usually only sued when there is a product liability, when the vehicle or one of its components is inherently dangerous. We will now propose some liability rules for a hybrid car like the Tesla Model S that is equipped with Level 2 automation. A hybrid car has certain operational design domains, ODD, which are the conditions in which the automated system is designed to operate. For example, cross-path traffic is a non-ODD situation for Tesla Model S. Even in automation mode, the driver is still supposed to have his hands on the wheel and actively monitor the driving situation. The hybrid car can be in either driver control mode or automation mode. In driver control mode, the liability rules should stay the same as the status quo since nothing has changed. The picture looks much more complicated in automation mode. In non-ODD situations, the hybrid car should not be in automation mode, which only the car manufacturer has the ability to prevent. In other words, the car manufacturer is the ultimate stick. Therefore, when accidents occur in automation mode in non-ODD situations, the manufacturer should be held strictly liable. This is exactly the situation of the Tesla Model S accident involving Josh Brown. At the time of the accident, the automation mode was on even though the car was in a non-ODD situation. The automation mode failed to notice the white truck against the bright sky. Since the Tesla Model S had no measure in place to prevent the driver from entering automation mode in non-ODD situations, Tesla would be held strictly liable. This rule will incentivize manufacturers to ensure that the automation mode will not be turned on in non-ODD situations. Level 2 automation systems of hybrid cars were designed specifically for ODD situations. Because the driver is supposed to maintain control, both the driver and the manufacturer are sticks with respect to their own tasks. Therefore, preserving the status quo may make sense. However, Because human drivers have cognitive limits that make them particularly poor at monitoring automation, we propose cutting the driver some slack and holding him only to a recklessness standard. Turning to fully autonomous vehicles, software firms will shoulder most of the liability that drivers face today. Software firms will be responsible for safe driving behavior. Autonomous vehicles must drive according to the rules of the road, especially under adverse circumstances. Firms take on dispositional agency, resulting in greater responsibility and blameworthiness. This sums up to a standard of strict liability. When an autonomous vehicle is found at fault in a collision, the firm will be liable. The abstract nature of the algorithms makes it impossible to point to a specific fault in the system. Instead, these companies shoulder responsibility because they are the least cost avoiders. Hardware manufacturers must uphold existing standards of car and part design. Additionally, they will need to ensure that their parts meet software specifications, so that they don't put a Ferrari's algorithm into a minivan. Hardware manufacturers will continue to hold strict liability. Car owners become almost entirely situational actors. The owner has no agency in driving, and so cannot be blamed for any accidents. However, owners will need to maintain their cars by replacing failing parts and applying software updates. Owners also have a duty not to make custom modifications, which could impair sensor detection, cause unexpected driving behavior, and just be plain dangerous. Owners really have to try hard to achieve liability, so they will be held to a recklessness standard. In summary, the primary liability shift takes disposition from owners and puts it squarely in the hands of software firms. In conclusion, the development of self-driving cars is creating major possibilities for tort reform of driving. Who is stick and who is ball will likely change dramatically in the coming years. In addition to the incredible technological opportunities, self-driving cars create new possibilities for tort law and driver liability.